Alright, hello, number 14. Things have been going good again. Still lots more progress, so I'm just gonna go straight into it because there's tons to cover. So, over the last 2 days, I'm working on cleaning up the general game experience now. So I want them. I want everything that the player is like interacting with to be a lot smoother and to get closer to an actual like playable thing that I can share with people and get good feedback on, and not like bad feedback. That's terrible. Anyway. So, we're gonna go over some really cool features that I've actually been working on. So the first one is improvements to the minimap when we're on the inside of the torus. You can see this dithering. I'm going to talk about how I did that. We can also see that there's fog in the distance inside on this. We can talk about the different things that I ran into related to that. Also going to talk about the adjustments to the camera control to actually work on the inside of the torus. You can see I can now draw on the inside of the torus now. The minimap, the little arrow on the corner, it now rotates with my character. So lots and lots and lots of little things. So we're gonna go through that. First thing, this dithering of the map so that we can see what's going on when on the inside. Part of the changes that I had to make to test this was obviously I needed to make it so I could very easily get to like start the game from the inside of the torus, map generated and all that stuff. So I changed some debug settings with that, so that's nice. And the way that this works, and I went over this just a little bit a few days ago, but the shader that I have, right, it has 3 different layers now, right? We've got the actual floor, so the map torus, the floor. We've got the outline, which is the black, it's this black voidness here, and I can show off a bit more of the void by like, you know, you can see that there's this like outline here. It's very subtle. And then there's also the dither, right? I can't remember if I actually went over this, but I'm gonna do it again. But the idea is that we just take the screen position at any pixel, right? So if we zoom in on this, you can see that this is like the dithering is constant in screen space, right? That's pretty important to make this like look nice, right? Because if we didn't do it like that and these pixels were like jittering around all the time, it hurts the eyes, right? So screen position of any pixel, we have some like threshold values, right? So we like scale the screen position to like make the pixels in the dithering larger. We pass it just through a regular dither function. We do use a dither threshold to say, so like the dither function, right? It takes the value that you pass in. Like imagine that you have like a big sheet. Oh, I have already gone over this. What am I doing? Okay, well, whatever. Anyway. Yeah, okay. You take a sheet, you've got different values for every single one of the things, and we scale it, we choose a threshold. Anyway, I'm now using this for generic objects in the scene as well, so you can see here. The secret to this is that I've now made a kind of generic shared shader that all the objects in my game are going to be using, right? So if we have a look at, let me just pull this up. If we have a look at terrain, so the wall prefabs, these things all use this terrain instance shader. Here we go. So all of my objects in the game now end with this shared subgraph, shader graph, right? So before, sending the base color and the alpha through, they just end with this thing, right? And this is neat. So, I'll shrink this a little bit. The idea here is that in the shader graph, you can create multi-compile keywords, right? So down here, we have keywords. These things they're like properties, except they create like an entirely new shader whenever you choose a different path of one of these things, right? And that's really important. So you can kind of think about it if you're writing HLSL, it's like a define, like hash define, e camera type, right? And then, there's going to be a chunk of code, but if you're, not on that specific branch, then it's going to use the other chunk of code, and the first chunk will not even exist, right? So this is the best way to optimize something if you've got an option that you only want, this is the best way, to do kind of branches, in my opinion, inside of the shader graph or shaders, right? If statements are bad, so if you can avoid an if statement, use a define if you don't need an if statement, right? So the idea is that when you have one of these things, and there's a little bit of weird stuff going on here, but let's ignore that. When you have one of these defines, right, you can, or these keywords, you can drag it out, and so you send the output somewhere, but these inputs are the actual branches, I guess. So you kind of read it from right to left, where you say okay, I'm gonna output. Let me just make sure. Yeah, okay. Redirect node. You go oh yeah, I'm gonna output a color, right? But if this enum, for example, is set to main, then we're gonna be fetching our color from position or something, right? Or if we're on the map, we're gonna be fetching it from the normal, right? We're gonna be doing something like this, right? And so when the enum is set to main, we're only going through this branch. This thing doesn't even exist. Really cool. Love that. Wow. And so what that means is that my minimap. Okay, so the way that I'm using that is that eCamera, right? Different cameras in my game can now go through different paths. And so I'm just going to give this to everything that I want to kind of have this shared feature list, right? And yeah, that's the idea, right? So the way that I'm, and this is how I'm doing this dithering, right? I think technically right now I'm doing this on all objects, right? So if I'm inside of this view, then yeah, you can see this stuff is dithered here. But that's literally just because it's going through all paths. So if I just change this to be you there, and you there. There we go. So now the idea is that, so for the map, right, we're going to be doing this. So this is the dithering step over here, and then map receive normal dither. Okay, this is a little, we have to do this and then on, and then you go like that. Okay, yeah. Sorry, we'll do this again. So map, and then we go, does the map receive the normal dither, right? So this is the keyword boolean. So if whatever this object does it receive dithers? So you can see here, map receive normal dither, map receive depth darkness. So these are the two values that I've been using. So if this object receives dither, go down this path here, right? Do all the dithering stuff. Otherwise, don't do that. Map receive depth darkness. If it does, then, apply darkness based off of the distance from the camera. If it doesn't, then just do the regular stuff, right? And the main and the UI path don't do any of this stuff, right? So this is cool. This is very neat. This is very cool, and it looks really nice in the game, I think, right? Obviously, I turned it off here, but yeah. Now, the way that I'm actually setting those enums, right? let's have a look at that. So we go to settings. So map. I made a render feature. This is the set keyword feature, right? And you can kind of see the settings here, right? So set a reference e-camera on so how this is gonna look. Let's have a look at this, right? And scriptable pass, new pass. So we're gonna create a keyword, right? So reference value so this is gonna be underscore e-camera underscore map, right? That's what it looks like. There's documentation about how this works, right? But I mean, if we have a look at the shader graph, then we can see, you know, this e-camera, right? The reference is underscore e-camera, and then we have the different value suffixes main, map, UI. So underscore e-camera, underscore main, underscore map, underscore UI. Those are how you access list values. And what this pass does, right, is when this runs, and I choose when. So we have a before rendering opaques, we're gonna set e-camera map to enabled, and then after rendering transparent, e-camera map disable it. And you can see it here, right? If enable builder set render function enable keyword disable keyword. So it just enables it and disables it specifically between those two states, right? And that just makes it so that any shader that cares about this specific global multi-compile thingy, like has that changed, right? So, and I have to make sure I don't generate a material property, because right now this is global because I'm not generating a material property. But if we have a look at this, so map receive normal dither value, this one generates a material property. And if we have a look at the terrain that we saw before, which was, gotta get it again. I have too many prefabs in my whole game. Oh my goodness. I just forget the name of this bloody thing. There we go. So you can see that these ones are here, right? So they're no longer global, right? They're kind of like material instance based. But we don't have to worry about that for this other one. And so when this thing runs, it's just going to set it. And the other cameras are going to have, you know, the main toggle. And so they're going to set the keyword to main, or they're going to set the keyword to UI, right? That's the idea. Yeah. And this is really nice so that I can actually have like more control over what happens to materials that are shown both in world and in the camera, right? That means I don't have to make as many materials. This is kind of overkill. I probably didn't need to do this, but I'm trying to save myself work, I guess, and yeah, maybe this is a little excessive. Anyway, so that's how I'm doing that dithering. The depth that I was working on, right? So this depth darkness, and we saw that in the game before, where like the minimap has like darkness as it gets a little further from the camera, right? Let's have a look at that. So you can see it there, right? That's darker. So back there, it's darker than at the front, right? So darkness, and yeah, and you can see that the tint changes a little bit. I was trying to do that darkness with a full screen pass before, and using the actual depth buffer to determine those things. That ended up wasting a lot of time, right? So let's go over that. So full screen materials aren't too hard to do. In fact, I've done them before. We have the skybox, right? So main, Ben, skybox, full screen. If we have an actual like look at this thing, right? View direction, scene depth, right? And I'm using the scene depth to just effectively enable and disable where the skybox gets shown. So technically things in the scene actually do kind of fade out as they get into the distance. I can't really show it, but they do sometimes. Yeah. Oh, actually, you know what it is? It's probably it's only opaques. Yeah, you can see this is fading out. It's fading, and it's like a transparent fade into the background, right? But it only affects opaques, and the reason that it only affects opaques is a little interesting, right? If we go to main, depth texture mode is after transparency. So technically, all of these things in the sky here, these are all rendered on the transparent layer. These things should be writing to the depth buffer, and this full screen pass, which is done, what is it? The skybox is done before transparency. But I mean, okay, this could be, even if I set this to after post. Okay, well, these things should be writing to the depth buffer, but they're not, right? They get hidden if this is done after the post-processing. And I'll show you the reason for that. And it's very, 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 very frustrating. So there's this render graph viewer, right? This is really handy. Actually, I guess I'll show you the other thing first. Analysis, frame debugger. Okay, here's where the actual, like, a good render of the depth is. You can see it here, right? So this is the depth of the scene, right? And as we go, like, later on, so draw transparent objects, we should be able to see the depth here, right? And again, it's a little tricky to see, but there is, oh my gosh, what are you doing? Go away. Okay, we can see that there is depth there. Yeah, you can see that there's these little objects in the background, and these are all transparent objects, right? Again, super hard to see, but you gotta trust me. So, the problem that I was running into, right, is if we actually look at this, right? So, just gotta try and find it. When I was trying to do my depth shader feature, so we go to map and full screen pass render feature. If we try to do this, right, full screen pass render feature, the depth this thing was receiving, it didn't used to have this one. Here we go. Full screen pass render feature. This thing didn't used to actually have any of the transparents. You can see it's missing, right? And I was thinking to myself, man, that's really strange. So let's look at the graph render viewer, and we can see we copy depth right before we draw decals, and before we draw transparent objects. Again, this thing is set to after transparency, but that wasn't working, right? That's really strange. Oh, what if I turn off decals? And you can see, this is the map camera. You can see that the decals being enabled forces the depth to get copied before transparency, right? And it just completely ignores the setting. This is a secret hidden thing that screwed me over, right? The secret to fixing this is you have to make your own render feature that copies depth, right? So Ben copy depth too, and I copy the depth again, and then suddenly the actual full screen pass that I'm gonna do actually has access to the depth, right? That was very important. In the end, I didn't actually end up using any of this, so I don't think I'm using either of these render features. and the minimap just looks fine like that, and I'm doing all of my kind of like post-processing. I'm just doing all of my depth darkness on these objects. The reason for that is because like I couldn't really get the depth back there, so I couldn't really know what to color these objects because I needed to include some transparency but not others, and it would have been like a huge pain in the butt to write all of that. So yeah, oh well. Anyway, things look good now, and the solution, okay, the summary is keep it simple. Actually, don't overdo it. Yeah, that's it. if you're gonna have like, if you need to apply like a darkness or shadows to everything, just put a shed shader on everything, and it's a lot easier than having to deal with what I was dealing with. So, alright, that's that. Now, the next thing that I was working on, right, was drawing on the inside of the torus, right, and controlling on the inside of the torus. So this wasn't very hard at all. I updated the map UI, so now what we have is there's this static class, so torus map collider. All right, this is the collider that we're going to be using to do anything on this minimap, right? There's now a different collider for the inside of the torus and for the outside of the torus, which, I mean, it was there, but now it registers itself when it enables, right? So a different collider gets hit here, and so we just recast onto that collider, right? This one, the normals are inverted, right? So when I raycast from the camera, it just hits the spot I'd expect, right? I was at one point just doing a reverse raycast, but you can see that on this position here, right, my cursor would actually be hitting the opposite side, so the far side of the torus, so I can't do that. I have to actually just kind of use these like reverse normals, which is fine, and it worked, so that's really nice. And the drawing kind of just came for free as well. This thing just draws over stuff, so I didn't even need to like worry about it. And the click and drag control thing, I made a bunch of other changes. It's just like improved now. Like when it like detects like whether or not I'm dragging when I'm not. There was one issue where if you dragged off of the screen, or like if you clicked off of the screen, right, and then clicked on, the camera would snap around. And the reason for that is that, so I'm using Unity's newer input system, right? The input system actions, stuff like that. So I'm using the new input system, and if you have an input that is reading the mouse position, it only gets updated while the game is in focus. So what was happening is that I was kind of like reading my mouse position over here. I'd click off, right? And then I'd click back on somewhere and it would like kind of snap, right? From that position to that position, and it would give me a massive delta, right? And so I'm recording the last position, and I compare it to the current position to get the actual delta for like how far it's gone, and it would just like snap over. So that was pretty bad, but well, we fix it by just kind of forgetting the last position when we're not in focus, right? Very easy to do. Nice little change. Yeah. All right. So that's another thing. The next thing, and this is going to be what I'm continuing to work on today, is I'm working on palettes, right? So every player that joins the game is going to have a different palette, right? So when they draw on the map, and I've already added support for this, right? We can look at the map drawing router. So whenever a player draws on or connects and then draws on the map, they get their own like map drawing tool, effectively. And these things are going to have colors like based off of the player color, right? And so while I'm setting up these palettes, I can use this little palette tester thing to I can add in a palette. So this is going to be my main character's palette for now, and I can set up their colors. So this is like the main color, so this is the one that's used by the minimap and all their drawing tools, right? Got to give it an alpha. So yeah, you can see that it's affecting the lines that they draw, right? And also I can set the color for them as well. So I can set up some like set of colors to make them like look cool or something, right? Like, wow, oh my gosh. And this is very fun to fiddle with. And I mean, technically this could be customizable. I don't know if I'm gonna go that far and do that, but yeah, I'm pretty happy with this palette thing. There's a lot of different ways to handle palettes. I've never done it like in a particularly nice way. This time I'm just saving into the settings and accessing it from the settings. So the idea is that we just have a palette struct, right? This thing is serializable. We've got a set of player palettes, right? We've got a fallback, so this is the default like whole palette object to use. This is what the settings actually initializes with, right? Get a player palette, we fall back to a default player palette if we don't receive one, right? And this is just like, you know, the struct that we were looking at before. And inside of the settings, we can find our references, this. So yeah, I've just added this as a value inside of my big settings object, and it'll show up in the settings. We can see it here, right? So player palettes, which is kind of interesting. So it means that players could like actually, I'm not gonna, you know, reveal this, but players would be able to actually tweak the palettes that different players display as. Yeah, it's kind of neat. And so what I'm working on today is tools so I can actually add in, or like while I'm deving, right, and debugging, I can just press like F1, 2, 3, 4 and swap between different players. Like it'll just like create a player and then swap me over to them, so that I control, you know, player 2, and then I can swap over to player 3 and control player 3, swap over to player 4, control player 4. That's my plan, and I think that's gonna work really nice. And it'll help me start actually testing real gameplay, because I want, you know, bosses and enemies and stuff to do attacks, like, and pay attention to, I guess, multiple people being around. It'll also help me test something that one of my friends was concerned about, where like the players, you know, get lost from each other. So if the map shrinks, so if we shrink the map a bunch, right? What if a player's over here and there's another player over here and there's another player over here? Like, what do we do? So that's yeah, that's an idea. All right. Anyway, thank you. Goodbye.